Today's lesson is on 3.5, inequalities, whoa, with variables on both sides. So there's your table of contents. Go ahead and put today's date over on the side, and we'll get started. So what we're going to do will be very similar to what you guys had in Chapter 2 with your solving. You notice we have x's on both sides of the inequality. First thing you want to do is get those on the same side before you start solving. Do you guys see how this x over here is just hanging out by itself? You want to leave that x there because there's nothing else on that side of the inequality with it. Alright, you probably couldn't tell, but I just paused the video because someone came into the room and I quick paused it before they came in. So I kind of forget what I was saying. I'm guessing I was talking about how you want to get the x's on the same side. You do want to leave this x alone by itself, which means let's get the 3x over here with the 1x. So to do that, it's a positive 3x. We'll subtract 3x from both sides. That cancels. 1x minus 3x is a negative 2x, is less than 8. And now when we solve for x, we're going to go ahead and divide both sides by that negative 2. And hopefully there's kind of a little bell going off on your head because we just divided both sides of an inequality by a negative number, which means that thing is going to flip. So instead of being less than, it's going to be greater than negative 4. So x is greater than negative 4. I've got a number line set up right here. Negative 5, negative 4 is in the middle, and negative 3, that's a 3, hard to tell. Alright, so we have to figure out, should this have an open or closed circle? Because it's just a greater than, we'll do an open circle on 4, and then greater than, so we're going to shade everything greater than negative 4. On a number line, everything to the right is greater than everything on the left. Alright, continuing to go through some examples here, we see this one has some parentheses, which means we'll have to distribute. We always want to distribute first, so we'll distribute that 6. 6 times 1 is 6. 6 times a negative x is a negative 6x. Carry everything down is less than 3x. Now we want to get the x's on the same side. Do you guys see how this 3x has nothing else with it? So we want to leave the 3x there. So I'm going to take the 6x and bring it over to the 3x. So it is a negative 6x. Let's go ahead and add it to both sides. That cancels, leaving us with 6 is less than 9x. Now at this point, students tend to kind of pause because they're thinking ahead in their brains, and they recognize that 6 will not divide by a 9. But don't let that stop you, because remember, we can get fractions in algebra. In fact, we get fractions a lot. We're still just solving for x, so we'll divide both sides by 9. That cancels. Now 6 does not divide by 9, so we're going to leave the fraction. However, can we reduce a 6 over 9? You can divide them both by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And then just carry everything else down. So 2/3 is less than x, but because I'm going to graph this, I'm going to flip everything around so the variable is on the left side. So I'm going to say x is greater than 2/3. So this is what we're going to graph. Now when you're graphing a fraction, instead of putting your 3 numbers, let's figure out what 2 numbers does 2/3 lie between. And 2/3 is between a 0 and a 1. And where is it between 0 and 1? Well, it's 2/3 of the way to 1, so it's going to be right around there. Another way you could think about that is if you take the space between 0 and 1 and divide it into thirds. So you can see I have, here's a third, there's another third, and another third. And we want our dot, or our circle, to be at 2 of those. So 2/3 is right there. Oops, that should have a 3. There we go. And then we need a circle, so we'll do, it's a greater than without the or equal to, so open circle. And then x is greater than, so shade to the bigger numbers, which will be that direction. Okay, this is the last slide for the intro video. When we simplify this, I see the parentheses right away, so let's go ahead and take care of that. We're going to distribute the 2. I'll go ahead and write everything down. Carry down the 2x plus 5 is less than or equal to 2 times 2 is 4 plus 2x. All right, so one thing I'd like to point out right now, do you guys see how there's a 2x on the left and there's a 2x on the right? So maybe you can predict where this problem is heading, but let me show you the math of what we do. We want to get the x's together. So let's say I want to subtract 2x over here so I can get it with this 2x on the left. Well, this 2x minus 2x cancels, and then I notice this 2x minus 2x cancels. So this is an example where your variables have canceled away on you. This happened last chapter as well with an equal sign versus the inequality. So we're going to follow through the same way. You're going to carry everything down. You have a 5, your inequality, and then a 4. So we want to pay attention to what this inequality is saying to figure out if this is a true or false statement. Is 5 less than or equal to 4? And we know that that's not true. 5 is not less than or equal to 4, so this is a false statement. When you have a false statement, our answer is going to be no solution. That'll seem familiar from last chapter. If that was a true statement, let's say we did our solving and we said 5 is greater than or equal to 4, and we say, oh yeah, that's totally true, then our answer would be all solutions. So you'll see some of that in the homework. So carry everything down and then pay attention to what that inequality is saying. That helps us figure out if it's no solution or all solutions.